Hi everyone, today we are going to discuss about matrices. This is one of the examples for the application of matrices. First, A passes the box to C. Next, C passes the box back to A. A passes back the box to C. In overall, there are three passes. This information can be easily represented through diagram. However, if we want to input this information into a computer, we need matrices to help us input this information into the computer. First, we label the column and row as A and C. Since they cannot pass the box to themselves, therefore A intersect A and C intersect C we label as 0. And then C only passes to A once, therefore column C and row A we label as 1. And A passes to C twice, therefore we label column A and row C as 2. This forms the 2 by 2 matrix. Let's move to example. Question 33. Given matrix A 1 1 1 0 1 2 2 1 1. Find the inverse of A. First, by using the elementary row operation. Second, by using the adjoint matrix. First, we need to know what is inverse. If there exists a matrix B such that A times B is equals to B times A is equals to the identity matrix, then B is the inverse of A. For example, matrix A 2 5 1 3, matrix B 3 negative 5 negative 1 2. A times B is equals to the identity matrix 1 0 0 1. B times A is also equals to the identity matrix. Therefore, inverse of A is equals to matrix B, while inverse of matrix B is equals to matrix A. Next, we need to know what is adjoint matrix. The adjoint matrix is the transposition matrix for the cofactor matrix of A. Let's get back to example. First, find inverse of A by using the elementary row operation. First, we write out the matrix A and write it in the augmented matrix form, which we write the identity matrix at the right side of the matrix A. Next, we compare the elements in column 1 first. In column 1, row 1 and row 2 already have the same element as the identity matrix. Therefore, we no need to change any element in row 1 and row 2. In the row 3 of column 1, in the matrix A, which it has the element of 2, while in the identity matrix it is 0. Therefore, we need to change the element of 2 into 0. We change it by using the cross multiply method. First, we write out the row 3 element as R3, and then at the bottom of it write 2. And then we write out the diagonal element from row 1, which is R1, and then write the element of row 1 as 1. Next, we cross multiply each other, and then we get R3 minus 2R1. Therefore, we need to change the whole R3 using this formula. After we have changed the row 3, the column 1 is settled. Next, we need to change the column 2. We compare the column 2 with the column 2 of identity matrix. The row 1 and row 3 element is different. Therefore, we need to change the element of row 1 and row 3 in column 2 into 0 and 0. We use the row 1 element cross multiply with the diagonal, which is row 2 of column 2, and then we get the new row 1 is row 1 minus row 2. And then the new row 3 using the same method, we get the new row 3 is row 3 plus row 2. After that, we have settled the row column 2. Next, we need to change the elements in column 3 using the same method. In the end, we will get the left side of augmented matrix as the identity matrix and the right side of augmented matrix as the inverse matrix of matrix A. Therefore, we have solved the problems. Therefore, the inverse matrix of A is negative 1, 0, 1, 4, negative 1, negative 2, negative 2, 1, 1. That's it. Next, we need to find the inverse of A by using the adjoint matrix. The inverse of A is equals to 1 over determinant of A times adjoint matrix of A. The determinant of A is equals to the element of first row multiplied with the cofactor of itself and sum of the product of elements and its cofactor. If we expand the first row, we'll get 1 times the cofactor of element row 1 column 1, which is 1 2 1 1 and minus 1, the cofactor of column 2 row 1, which is 0 2 2 1 plus 1 times the cofactor of column 3 row 1, which is 0 1 2 1. And then we use the determinant formula, which is AD minus BC. We'll get finally the determinant is equals to 1. Next, we need to find the adjoint matrix of A. The adjoint matrix is the transpose of cofactor matrix of A. In order to find the cofactor matrix, first, for the element row 1 column 1, we need to draw a line to cover the element in row 1 and column 1 of matrix A. The remaining 4 elements will be our cofactor element in the row 1 and column 1 of cofactor matrix. For row 1 column 2, we cover with the matrix A with the line row 1 and column 2. The remaining 4 element, which is 0 2 2 1, will be our row 1 column 2 cofactor element. And then we repeat this step for all the other 7 elements, and then we get the cofactor matrix. After we have write out the cofactor element in matrix form, we need to solve the cofactor into numerical digit. Each cofactor matrix, we can solve it by using the formula AD minus BC. Therefore, for the row 1 and column 1 element, we get the numerical value is -1. We repeat this step for all the other 8 elements. Don't forget to add negative in front of it if it is necessary. After we have found the numerical of all the cofactor matrix, next we need to find the adjoint matrix by transposing the cofactor matrix. At the end, the adjoint matrix is equals to -1, 0, 1, 4, -1, -2, -2, 1, 1. And then we have the determinant and adjoint A. We can find the inverse of matrix A. Substitute in the value of determinant of A, which is 1, and adjoint matrix of A. 1 over 1 is equals to 1. Therefore, the inverse matrix of A is equals to -1, 0, 1, 4, -1, -2, -2, 1, 1. That's it for this question. Thanks for watching.